Okay. So batch will start now with assignment number 2. Assignment number 2 is, I'll first of all read for you. Design a distributed application using MapReduce, which processes a log file of a system. List out the user who have logged for maximum period on the system. Use simple log file for the internet and process it using pseudo distribution mode on Hadoop platform. Okay, so this is your second application which you all will be implementing on Hadoop platform. Okay, so for this, first of all, we'll start with a simple Hello World program on Hadoop. Hello World program in Hadoop. So what Hello World program is? So I'll give you demo for word count program in Hadoop, word count program in Hadoop. So now basically what do I mean by word count program? So if I Google it and if you type word count program in Hadoop, so I'll just open one image. So this is the Hello World program in Hadoop. Say for example, I have an input file, input.txt, in which I have some set of words available with me or present in that file. So what program I'm writing in word count program is, that program will count the frequency of every word present in input.txt file. For example, in this, different words present are bus, car, train, plane, car, bus, plane. So here now what will be the output of word count program will be, bus is coming how many times, car is coming how many times, train is coming how many times, and plane is coming how many times. Okay? Yes? So for this, I'll be writing a word count program on Hadoop. So as I have told you, Hadoop gives you facility to store your data and to process your data. So whenever we store our data, that data gets stored in a HDFS, that is Hadoop distributed file system. And whenever I want to process that data, so whatever data I stored on HDFS, so that data gets processed using MapReduce processor, Okay. So now what do I mean by, or whenever we store our data on HDFS, what basically happens? Okay. So right now we all are using normal local file system. So whenever you want to store your data, what happens is uh, you store your data straightforward onto a hard disk. So whenever I store my data on a hard disk, my data gets stored on my hard disk on different sectors, So I'll draw what do I mean by sector and tracks, so we'll get a better understanding. Yeah. So whenever you store your data, so we store our data on hard disk. So say assume this is my hard disk. So in my hard disk is divided into different tracks, and every track is divided into number of sectors, and every sector size is 4 KB. Every sector size is of 4 KB. So this criteria or this scenario is in which case local file system. Local file system. So right now when you are using your normal Windows operating system, we are referring to a local file system. So how my data gets stored? In 4 KBs of blocks, So assume I have a 200 KB of data and I want to store that on my hard disk. So how I will store this data? 200 divided by, what is my block size? 4 KB. So 200 divided by 4 KB. So whatever will be the value. So say the value will be 200 divided by 4 equal to 50. So how many blocks I need is? I need 50 blocks to store my data where the block size is what? 200 KB. What is my data size is 200 KB and block size for local file system is what? 4 KB. So if just imagine just to store the small amount of data which is having size 200 KB and this data I am storing it on my local file system, how many blocks I need is 50 blocks I need. But now assume I want to store a big data on my hard disk, big data on my hard disk. So say we'll assume right now the big data size is of 5 to 100 MB. So right now we are just taking an example, 200 MB. Now this 200 MB of data, if I want to store it on a local file system, definitely I need thousands of blocks to store my data on local file system, on local file. So for that, what Hadoop gives you is, Hadoop is basically what? Hadoop is an open source framework. Hadoop is an open source framework which gives us facility to store our big data, and to process our big data in efficient manner. So when we store our data, we refer to the HDFS, and when we process our data, we refer to the MapReduce. We refer to the MapReduce. Okay. So now what is difference between HDFS and local file system? In local file system, what my hard disk, whenever I try to store my data, my sector size is what? 4 KB size. 4 KB size. But in HDFS, HDFS is installed on the top of local file system, on the top of local file system. This is my local file system, and whenever I install a Hadoop, my HDFS file system gets installed on the top of local file system. So what happens when I use HDFS? So my block size becomes 128 MB. 128 MB. Okay. So now instead of having a block size of 4 KB in HDFS, I'm using block size of 128 MB. 128 MB. So this was the block size of local file system. This is the block size of HDFS file system. Okay, 128 MB. So now if I want to store this 200 MB of data, how many blocks I need? 200 divided by 128. So maximum you need is 2 blocks of data. Whereas the similar data, if I want to do it using local file system, what I need is 200 MB divided by 4 KB. So definitely this N is what? The 1000 number of blocks I need. 1000 number of blocks to store that data. So to divide that data into those N number of blocks and to store, which is very time consuming, rather than storing your data into 2 blocks only and to store that data. So definitely my HDFS is a better solution when I'm dealing with a big data, right? But if you want to store a very small amount of data, like 2 KB of data, using HDFS, definitely my block size is of 128 MB. So just I'm using only 2 KB block out of this 128 MB. So the rest of the memory is getting wasted. So definitely will not use this HDFS for a small data. We'll be using this HDFS for big data. Okay? Yes? So Hadoop is used to store and process our data. So when I want to store data, we use the HDFS. HDFS block size is 128 MB. Okay. Now we'll go back to our word count program. So here, assume that this is my big data. This is my big data. So assume this is of 200 MB block. Okay. We'll take it more than 200 MB. Say 300 MB data. Okay. So this file size is 300 MB, where I have certain set of words present in this. Now I'm writing a word count.java program, which is a distributed application and which is giving me output, which is in the format of every word is coming how many times. Every word is coming how many times. So this process, which is in between input and output, which actually counting the frequency of every word. So for this, we are using a map reduce process. For this, we are using map reduce process. Okay. So now just now we have discussed. Then I want to store my data. Definitely this input.txt will be where? This input.txt will be present on HDFS. Okay. So how many blocks I need to store 300 MB of data? How many blocks we need? So just now I have opened the calculator. I'll show you. So if I am using 300 MB data and a block size is 128 MB. So I need two full blocks and partially third block, partially third block. Yeah. So if you see here, this first split is my first block. The second split is my second block. This third split is my third block because this file is stored in three blocks. So in MapReduce, we have the concept called as mapper and reducer. Mapper and reducer. So what mapper does, how reducer works, this we'll see in depth in unit 3. Okay? So this is when you start processing your input.txt, which is stored on HDFS. So during that, we divide our program into number of splits. So who decides how many mappers will work, and so that will be decided by the number of blocks we need to store that input.txt. So right now we have assumed our file size is 300 MB. So how many splits will be there? How many blocks we need to store this file is 3 blocks. Okay. So when we say I need 3 blocks, so in MapReduce, how many blocks? Those many mappers we need to process that data. So if I need 4 blocks, so that is called as a 4 splits. So 4 splits, 4 mappers. 5 splits, 5 mappers. So आपका file size क्या है? Depends on that. The mapper requirement is there in MapReduce program. So this is my first block, second block, third block. So on this, we are running a mapper. So what basically mapper does is, mapper reads every word from that block and it will generate an output in the format of key comma value pair. Key comma value pair. So what is key? Key will be your word and value will be always constant, that is 1. That is 1. Because for the first time bus is that mapper is reading bus for the first time, car for the first time, train for the first time. Again, if again bus will come, again bus comma 1. Similarly, on second split, the mapper is working. It is giving output as key comma value pair. Again here, same key comma value pair. Then the intermediate step is shuffle the data. Means what I want the output is bus is coming how many times. So what this shuffle stage will do is it will shuffle similar words all together in one block. So bus is gathered all together because these are the similar keywords. Car is similar keyword, train is similar keyword, plane is similar keyword. Then reducer, what it will do is it will just reduce this value together. So bus 2, bus 1, so bus comma 2 comma 1, so 2 plus 1 will come as 3. So the what reducer does is reducer reduces this value to its summation. So bus comma 3, car comma 2, train comma 2, plane comma. And this is what my output of the reducer after combining is this key comma value pair, where I get how many times this keyword or this word is coming in this input.txt. So this is what the word count.java program. So this is a hello world program in Hadoop. So why it is called as a hello world program? Because to store our file on Hadoop, then to to write a program in Hadoop, Java program in Hadoop, then compile that program, create a jar, then providing an input, generating a key comma value pair. So for that, we need to follow certain steps on Hadoop. Okay, so that I'll be demonstrating it right now. So now we'll go to our virtual machine. So in virtual machine, I have already started this image. So we'll go to that image. This is my image. So if you see, okay. So in this virtual machine, if you see, this is your introductory introduction or welcome page. Okay. So in cloud era, this is how your desktop look like. This is your desktop. So on this, if you see in cloud era, inbuilt Eclipse setup comes. So when we'll start with the distributed application, we are writing our program in Java. You can write it in Python, you can write it in C++, but in our syllabus, they have recommended we have to write our Hadoop application in Java. So I'm opening this Eclipse IDE. After opening this Eclipse ID, whatever we did in OOP second year, first semester, similarly, you have to create a project and you have to create a class file and so on and so forth. So I have already explained this for one of the batch. So I'll demonstrate you once again how to. I'll just close this project and we'll start with a fresh one. Okay. So go to the browser first of all. Search in Google word count program. So we'll be taking a ready-made program from the internet. So word count program in Hadoop. Center. So just go to the hadoop.apache.org site because this product Hadoop framework is launched by the Apache. It's a project of Apache only. Just click on this. On this. Go to the source code. I'll show it to you again. After opening this, just go to the source code and copy this source code. Go to the Eclipse. Go to File. Select New. Create a Java project. Fine. First step is to create the Java project. So I'm giving name of my project same as my class file. So my W is capital, C is capital. Okay. So word count is the project name. So it is saying now already exists. So I'll say word count 1. Okay. Next, finish. So now my project is ready. Now second step is in this project you add a package. You add a package. So it is compulsory to add a package when we are writing a distributed application on Hadoop because while creating a jar file, now why jar file I'll explain you afterwards. But in Hadoop, whenever we want to run a Java program, we never run class file directly. We have to create a jar of that and then that jar will be executed on Hadoop platform to get the output. So for that, in that command, we need a package. So for that, first of all, after creating a project, you need to create a package. So here the package name and project name I'm keeping same, word count. Okay, yes, say finish. Now my package is created. So first step is what? Create a project. Second step is create a package. Third step is create a class. So go to the file, go to new, say class. Class name should be same again. So word count 1. Word count 1. So okay, here I have given word count. Fine. So just give the name of class file as same as project name. Say finish. And okay. Before that, click include main method in that. Say finish. Okay. Now whatever program we have copied from here, copied from browser, we'll just paste it in Eclipse. We'll just paste it in Eclipse. So package keep as it is. Just paste this. Just paste this code. Now here my package name is word count, but my class name is what? Word count 1. Word count 1, right? Yes, word count 1.java. So I need to make changes over here because my main function is in which class? Word count. It should be in word count 1. So this we have already learned, right? So make that change. And second is when you go to the main method, just this line job.setjar by. So here make this name as word count 1. Okay? Yes? Okay. So now package is created, sorry, project is created, package is created, class file is inserted, code is ready. Now what is next step? So as you all can see now, so many errors are there. So these errors are coming because of what? Because of whatever package we are importing, this package help file is not present. This package configuration files are not present in this environment. So for that, we need to link those files in our project. Okay? So how to do that? Just go to the project, right click on this, then go to the build path and click on add external archives. Okay? I'll tell you again. Right click on project, go to the build path, click on add external archives. After clicking on this, you will get something like this. So just go to the USR or click on file system. This is your file system. Click on USR. Double click on this. You will get this folder. So inside this, double click on lib. In lib, we have a folder called as Hadoop. So what is path? User lib, go to the Hadoop. Okay. So in Hadoop, we have a Hadoop dash common.jar. You click on this and click this jar in your program. If you see now, this few errors have gone. So whatever Hadoop dash common.jar, so this jar file we need for this package import. Okay. Now still we have some errors. So we need to import Hadoop.MapReduce jar as well. So how to do that? Again, right click on project, go to the build path, click on add external archive, click on USR, click on double lib, then you click on Hadoop. Now पहले हमने कौन से पिक किया था click Hadoop. Now you click on Hadoop dash 0.20 dash MapReduce. Click on this, then you will get a file called as Hadoop dash core dash 2.6.0 dash MR1. So just click on this. Just make sure it should be Hadoop dash core file. Huh? It should not be examples or something like this. Just click on this, say OK. Now my errors are gone. Okay, so my program is ready to run. Ready to run. Okay. So what first step we did? We have created a project, then we created a package, then we created a class, then we added an external archive. Now next step is what? Now next step is to run the program. To run the program. So now what is the input for our program is input.txt in which I have specific set of words present with me, right? So here I have created one on desktop. If you see on desktop, I have created one file input.txt. So I'll create once again for you all. So I'm creating a folder named as input. I is capital. Inside this, I'm creating one document, empty file, input.txt. Okay? I'm just double clicking on this and I'm writing some words inside this. So I'm writing few words. So I'll just copy paste. So it will save our time. So this data, I'm just pasting it in my file. I'll save this. So this is my input txt in which I have few keywords, few words I have written. So now my program word count or Java will count. Rupali is coming how many times? Nishu is coming how many times? Prabal is coming how many times? And Meena is coming how many times? Okay? So my input.txt is ready. What is the path? On desktop, I have a folder input. Inside this input folder, I have a input.txt. So right now my file is on desktop. So now to run this word count.java program, this input.txt should be present in a Hadoop environment. Okay, this is Cloudera desktop. Now I want to copy this input folder where I want to copy this input.txt into a Hadoop environment. So how to do that? So for that we will be doing some commands. We'll be running some commands on terminal. On terminal. So for that, if you see on this top bar, there is one PC sign. Just click on this. Just click on this. So this is your shell for similarly as Linux. So type pwd. Pwd stands for present working directory. So it will show you where right now you are. So slash home slash Cloudera is your current working path. So this is where my Hadoop is working. In this path, my Hadoop is working. And where my file is, if I type ls, ls is list the files. So my file is where? On desktop. My file is where? On desktop. So where I want to copy from desktop to home Cloudera. So for that the command is what? Command is what? Copy. So okay. So I'll just copy that command. So every Hadoop command is prefixed by Hadoop fs. Hadoop fs. Okay. Otherwise, the normal Linux command, same commands you all will be using in Hadoop platform as well on shell. Only that command will be prefixed by Hadoop fs. So Hadoop fs, to copy file from source to destination, the command is put. So hyphen put. Then where my file is on desktop. So capital DS, press tab, desktop. In that I have an input folder. In that my file is input.txt. Where I want to copy? I want to copy it in a current present working directory. So simply type the file name which I want to copy it as. So you can give different file name as well. So what this command stands for, Hadoop FS is a prefix for which command? Copy. Put command is to copy from source to destination. Okay, press enter. Now my file is copied from desktop to Cloudera. So now my this input.txt is already present in Cloudera. Is already present in Cloudera. So what I'll do is I'll rename this to input1.txt. So my file is copied. Okay? Yes. So now my program is ready. My input is ready. Now I'll execute my program. So to execute a program, we need a jar file. We need a jar file. Okay? So for that, how to create a jar file? So for that, again go to the Eclipse. Okay? Then right click on your program. Right click on your program, word count1.java. Okay? And just go to the export. And here you will get these options. So inside this, click on Java, click on jar, say next. So for which program I want to create a jar file? Word count one. What should be the name of my jar file? That you can click on this and you can give a name of your jar file. So here I am keeping jar file name as word count one. Okay, word count one.jar. Okay, say next, next, finish. Your jar is ready. Your jar is ready. Now we'll execute our program on terminal. So now here last tab is the terminal. Click on this. So now how to execute a jar file? How to execute a jar file? So for that the command is again the prefix Hadoop FS. Then what is my jar file name is word count. I think it was W capital, P capital, word count one dot jar. Then syntax is what? To run a jar. So for that the command is Hadoop, sorry, Hadoop, run a jar file. For that the command is jar. Okay. Which jar I want to run? The name of that file is word count one dot jar. Which program? What is my program name? What is my class name? Word count one. Right? See, what is my class name? Word count one. Okay. What is my package name? What is my package name? Word count. So here package name dot class. Package name dot class. So my package name is word count dot. What is my class name? Word count one. Where what is my input file name? Input1.txt. And next is I want to give a output path. मुझे क्या देना पड़ेगा? Output path. So what should be the output path? So I'll give one. I'll create a directory in current environment. So name of the directory I'm giving as directory 2. So I'll explain the syntax again. How to run a jar file? The syntax is Hadoop jar, which will run our jar file. What is my jar file name is word count one.jar. What is my class file in which my main method is there? Word count is the package name dot word count one. What is my input? Input one.txt, which is present in a current working directory, where my output will go in a directory 2 folder, which again in a present working directory. Press enter. So now your map reduce process has started. So now there is some error. Let me check because we have changed the file name and all. Okay, it says input1.txt not present. Okay, I'll change it to input.txt. I'll just clear this desktop. Okay, this capital I is there. So it's a case sensitive. Press enter. So my map reduce process has started now. Okay. So how many mappers we need? Just now we have talked about. Now our file is very small, which is definitely it is of less than 128 MB. So how many mappers we need? Only one mapper. So see, initially map and reduce was 0%. Now map 100%. Now the reduce process has started. And after all operations done, if you see job counter, how many mappers we need? Only one. And how many reducers we need? Only one. So once this is done, now I want to check my program, what is my output of my program, right? So for that the command is Hadoop dfs, or you can write fs as well. Fs hyphen cat. Cat shows the content of file. What is my directory name? dir2. So by default, the output gets stored in a file name called as part hyphen r hyphen 5 times 0. Enter. So this is what my output is. Meena is coming 1 time, Nishu is coming 6 times, Prabal is coming 2 times, and Rupal is coming 11 times. Okay? Yes? So now you can check PWD, type karo. Oh, okay, sorry, LS. So you can see dir2. Okay, it goes to the actually present working directory, which is in cloud era. I think it is hidden. Okay. So ls is command to list all directories files present in a current working directory. So this is what my output is. Now what precautions you need to take is, whenever next time you will run your program, your output directory name should be always different. Always different. So I'll show you what problem comes. If I am running same program with dir2 again, अगर मैंने कुछ प्रोग्राम में चेंजेस किए और मुझे फिर से प्रोग्राम रन करना है, तो आउटपुट डायरेक्टरी नेम शुड बी डिफरेंट. By mistake, if I keep it as same and if I try to run this, it will give you an error. It will give you an error. So what this error is, dir2 is already exist. dir2 is already exist. So what you need to do is you need to change this name to something else, dir3. Then the program will run. The program will run successfully. Okay? Yes? So this is what the demonstration for assignment number 2. So now you all have to practice this word count.java, and once you are comfortable with this, then we'll start your actual program distributed application to process a log file. Process a log file. Okay? So we'll stop here.